Today we learned about the law of cosines. So the law of cosines involves three sides and one angle in a triangle. And this is the equation for the law of cosines. Little a, little b, and little c are side lengths of the triangle, and the big C is the angle. So this is very useful anytime you have a problem involving three sides and one angle. For example, suppose I have a triangle here. I know this angle is 36 degrees. This side length here is 52 centimeters. This side length here is 45 centimeters, and I want to know this side length. So as you can see, I'm working with three sides and an angle, so the law of cosines is going to work well here. So the first thing I do is I label everything. The angle I'm working with is always going to be my vertex C, and the other two vertices, you can label either one A or B. They're interchangeable, so it doesn't really matter. The side across from angle C is my little c. The side across from my angle B is little b. And the side across from my angle A is little a. So now I can write an equation using my law of cosines. C squared, which is what I don't know, C squared equals A squared, which is 52, plus B squared, which is 45, minus 2 times A times B times the cosine of angle C. And the cosine of angle C would be the cosine of 36 degrees. Now, the good thing about this is because I'm using my graphing calculator, it can actually do this whole thing for me. I could literally type in this entire thing into my calculator, okay? Or I could simplify it. I mean, it doesn't really matter. I'm gonna actually type it in. 52 squared plus 45 squared minus 2 times 52 times 45 times the cosine of 36 degrees. And boom. C squared is approximately, I'm going to round to the hundredths, 942.80. So I'm almost done, but remember, I'm trying to find C, not C squared. So I'm going to square root both sides, and C will be approximately square root, and I'm going to use my previous answer button, square root of the previous answer, about 30.7, rounded up, 1 centimeters. So the length of that side is about 30.71 centimeters. Now, the law of cosines can also be used to find missing angles if you know all three sides. So my second example here, here's another triangle. It's probably not to scale. 225 centimeters. This side's 250 centimeters, so it's definitely not to scale. 175 centimeters, and I'm trying to find this angle right here. So again, three sides and an angle that I'm working with, so I'm gonna use the law of cosines for this. All right, so the angle I'm working with is always gonna be C. The other two are interchangeable. I'm gonna label the sides across from the angle. There we go. Now I can write my equation. All right, so I know that C squared, in this case I know C, 250 squared equals A squared plus B squared minus 2 times A times B times the cosine of C. And this is where we finally get to our unknown. So as you can see, I'm going to eventually have to use my inverse cosine function to get to C. But let's simplify some things, all right? So 250 squared is 62,500. 225 squared is 50,625. 175 squared is 30,625 minus 2 times 225 times 175 is 78,750 times the cosine of C. Now this is where simplifying gets a little tricky for some kids. A lot of kids want to do this plus this minus this, but you can't. This is attached to the cosine C. This is being multiplied by the cosine of C. These two are not being multiplied by the cosine of C. So we can combine these two together to get 81,250, but that other number, 78,750, is being multiplied by the cosine of C. So I gotta leave that there for now, okay? Now, solve this equation and I can get my missing angle. I'm gonna subtract 81,250 from both sides. I get a negative 18,750 equals negative 78,750 times the cosine of C. Now I'm gonna divide both sides by that negative 78,750. I'm finally going to get to the cosine of C. This, if I do this on my calculator, it comes out to approximately 0.238. And it's a positive 0.238 because I'm dividing a positive by a positive. Now, to get C, I'm going to have to use the inverse of cosine. So C is going to be the inverse cosine of 0.238. So whatever that is going to be my answer. And if you type that into your calculator, it turns out that that comes out to about 76.23 degrees. Okay? So there you go. Two examples of using the law of cosines. One where you're trying to find the side length, that's this one, and one where you're trying to find the angle, that's this one. As you can tell, finding the angle takes a little bit more work. Finding that missing side length is actually pretty easy. It's just calculated work. All right, but work carefully because there's a lot of steps to these.